Good evening, everyone. As we all know, astronomy is one of the oldest sciences. I always had an interest in astronomy, even when I was a kid. I had seen my father reading books of Isaac Asimov. He also shared his experience of listening to Stephen Hawking in January 2001, where he delivered the Albert Einstein lecture at the Shreveport Auditorium. To be very frank, I didn't understand about astronomy that point of time, but in the back of my mind, I had a lot of unanswered questions. I'd listened to Dr. Debiprosad Duari on a TV interview about Chandrayaan 2. His speech was so engaging, which gave us a vivid knowledge about our mission to the moon. Every one of us today must have gone through a similar experience while seeing a night sky or even viewing the solar or lunar eclipse. Humans are naturally curious, and the cosmos is the biggest mystery. Inherently, I think that humans are generally explorers. Some are hunter gatherers, and these humans are typically inquisitive and want to know the how and why behind what they observe. So we end up exploring and hunting for gathering information, and what's better quest than delving into the depth of the solar system or the universe. That is where the unknowns, the truth, the missing God, and the ultimate frontier lies. Now I will request Pratyush to introduce our speaker formally. Thank you.
Good evening, everybody. Today, I, Pratyush, would like to introduce our speaker for the evening. Our speaker for the evening is Dr. Debiprosad Duari. Dr. Debiprosad Duari is an internationally renowned astrophysicist, educationalist, and researcher. Professor Duari is the Director of Research and Academics, MP Birla Planetarium, and MP Birla Institute of Fundamental Research. He is associated with a number of distinguished, prestigious, learned bodies and institutes, including the University of Cambridge and Manchester University of Science and Technology, UK, and the Institute of Advanced Studies in Iran. He is also the fellow member of different glorious and dignified organizations. Thank you very much.
Now I would like to tell some of the rules and regulations. Everyone present here is requested to keep their mics and cameras off. Active participation will be appreciated. And during the question answer session, audience can type their questions in the chat box and all of them will be addressed by our speaker. Thank you.
Thank you, sir. The stage is all yours.
Okay. A very good evening to everybody present for this webinar. It's a wonderful feeling for me, and I thank the authorities of the Tagore International School to give me this opportunity to talk to young minds. It's also my passion to tell young people, general people, about the cosmos. Because in my last 35 years, I have realized that quite often questions do arise in our minds, and these questions sometimes the answers can be found only in the dark depth of the cosmos or about their understanding. So in this particular circumstance, I have chosen the topic of my lecture as the cosmic consciousness. Now, some of you may have read or seen the word cosmic consciousness in terms of mythology, in terms of philosophy, in terms of spiritualism. But my objective is not to go in those directions. Just the sheer understanding of our cosmic environment and to slowly trying to understand that whatever we do, whatever we are, whatever is going to happen, there is a cosmic connection to everything about it. And that is the reason I have chosen the title of this topic as the cosmic consciousness of a common person. So I will give a presentation, a PowerPoint presentation. So now let me just present myself, my PowerPoint presentation in this screen. Well, good. Our cosmic consciousness. So as I was just mentioning, from time immemorial, human minds sometimes have looked into the dark depth of the sky and wondered not only about those objects, about those events, but whether there is any connection, metaphysically, physically, or otherwise. And from those days onward, there was an endeavor to go out into the dark depth of the cosmos and explore it. Here by the word going out, I don't mean physically going out, but to have instruments, to make facilities which can help us to look into the dark depth of the cosmos. And that is the reason also there is a tremendous amount of interest nowadays with the cutting edge technologies that we are availing of to know much deeper into this subject. Thousands of years back, when our ancestors used to look into the sky, they used to wonder, what is sky? Where is sky? What are those lighted dots we call stars? And is there any connection between the star and the earth? With these set of questions and queries, the subject of astronomy was born. So astronomy can be considered as one of the oldest subjects that human minds have dwelt upon. At the same time, given the huge number of news items that you regularly get to see in television channels and newspapers, you get an idea that it is also one of the most happening subjects in the recent era. Astronomy, the subject, has a power. It can tell us what was the physical situation in this particular, say, region of the world millions of years back. At the same time, it can give us a hint what can be the situation in this particular region millions of years later. So spanning a vast expanse of space and time, the subject that deals with astronomy. And scientists are realizing that soon the 21st century will be termed as a century for astronomy and astrophysics. And that is the reason also throughout the world there is a tremendous amount of activity in terms of preparation to know the space. Just to give you an idea, in this inhospitable terrain in the Pyrenees mountain of France, they have built this observatory. The cost of building this observatory was around $300 million. One of the smallest island, Hawaiian archipelago island called Mauna Kea. On top of Mauna Kea, 6 countries have created 9 observatories. The smallest one cost is around $500 million. So that tells you what a gigantic amount of effort is going on in terms of understanding the sky. But you'll be happy to know that it's not only the optical wavelength, the radio wavelength is also being used to understand the cosmos. And huge instruments. For example, take this photo. It's around a 100-meter disk in Effelsberg in Germany. And using these sort of huge instruments, scientists are trying to peek into the deepest part of the cosmos. But the happy story is that the largest telescope is not yet born. The work has started in 2014, and it is probably going to get commissioned by 2023. The world's largest telescope will be termed the TMT, 30-meter telescope. The cost of building this telescope is so huge, not a single country is able to build it. So 5 countries are collaborating to build this telescope, and one of the main countries in the collaboration is India. The Indian government has decided to spend 1,600 crore rupees as its contribution to build a part of this telescope. So you can see India is becoming a tremendously important place where astronomy, astrophysics, research, studies, and technological breakthroughs are happening. Not only in optical, we all know about this huge program, the mega project SCAR, Square Kilometer Array. It's a tremendously huge array of radio antennas, 200 dish antennae in South Africa, and 180,000 small dipole antennas in Australia. Together, when they'll be looking into the space, they'll produce 10, 15 times better resolution images than that could have been produced by any single radio telescope. And you'll be happy to know India is one of the proud associates of this SCAR program. Not only that, 2016, in 2 laboratories in US, suddenly they discovered an amazing fact. The fact was predicted in 1916 by Albert Einstein when he gave his general theory of relativity. From that, we could make out that if two heavy compact objects are going around each other, they will produce a wrinkle in the space-time. This wrinkle, which goes by the name gravitational wave, will pass through one end of the cosmos to the other end at the velocity of light. And these predicted gravitational radiation or gravitational wave was discovered in two laboratories in US called LIGO, Laser Interferometric Gravitational Observatory. And India, again, is one of the proud partners, and they have started the process of building INDIGO, Indian Gravitational Observatory. So, my friend, from the Indian context, it is a tremendously important and interesting issue to talk, discuss, and research about astrophysics. The night sky. Thousands of years back, when our ancestors used to look into the night sky, they used to wonder what is the meaning behind those lighted dots, but they couldn't find an answer. But in their desperation, what they did, they chose different parts of the sky, identified closely spaced stars, joined those stars through straight lines, and created imaginary figures. And this way, the whole sky was divided into 88 regions, each region being governed by an imaginary figure which we today call constellations or Taramandal. You may be wondering that these are all imaginary things. Why should you know about them or their names and so on and so forth? But the problem is, these objects, these concepts, this imagination, even today, are useful. For example, you have gone on a hitchhiking trip, night has happened, moon is not there in the sky, you have lost your way. Suppose somebody in the morning told you that if you go in the southern direction, there is a locality. But which is the southern direction? If you happen to see the Saptarshi Mandal, 7 stars, like which are called Big Dipper in Western parlance, take the last 2 stars, join them in your mind, produce it onto the sky. It will hit upon a single star, and that star is called the pole star. The moment you know the polaris of the pole star, you'll know which is the north, south, east, and west. So even today, these sort of imaginary signage do help us in our regular life. Let us now talk about the Earth and the sky surrounding it. Let us consider the Earth at the center and the sky like the inside of a globe. Take the equator of the Earth in your mind, produce it onto the sky. It will create a great circle, and let us call it the celestial equator. Now I think you have all read that Earth is going around the sun once in 365.25 days. But if I ask you to prove it, it becomes a little laborious and difficult sometimes. But somehow we know it is going around the Earth, around the sun. But what appears to us? It appears to us as if sun is going around the Earth once in 365.25 days. Why? Because sky to us is just a two-dimensional surface. Along the line of sight, if we look at the sun, it will be projected onto a part of the sky. So, as we are going around the sun, it appears to us as if sun is going around us. This apparent path of the sun on the sky is called the ecliptic, the loci of eclipses. Now again in your kindergarten days probably you have learned that Earth is going around the sun around an axis, and it goes round itself once in 24 hours around another axis, and these two axes are not parallel. They're inclined at an angle of 23.5 degrees. But a lot of our teachers probably must have forgotten to tell us, just because they are inclined and not parallel, you people are here today on Earth, you, me, 780 crore people, and millions of life exist on the surface of the Earth. If these two axes were parallel, there would have been no life on Earth. I'll come to that. But since these two axes are inclined to one another, two imaginary planes, the yellow-colored ecliptic plane and the blue-colored celestial equatorial plane, they will intersect each other along a straight line. And this straight line has two endpoints. The first endpoint is called the point of vernal equinox. The word equinox comes from Latin. It means equal nights. 22nd or 23rd of March, sun appears at that point. That date is exactly equal amount of daytime and nighttime everywhere on the Earth. March, April, May, 21st or 22nd of June, sun appears at the northernmost point. That day it is the longest day and the shortest night for the northern hemisphere. 22nd September, sun comes over here, again equal amount of daytime and nighttime. And 21st or 22nd of December, sun comes at the southernmost point. That day, at least for the northern hemisphere people, it is the shortest day and the longest night. So this continuous variation of daytime and nighttime occurs just because of this accidental tilt of 23.5 degrees. Now, if I go to the solar system, because that is the beginning of our journey in some sense, talk about the sun, earth, and the moon. You may be wondering what is there, because we have all learned it in our LKG days probably. But amazingly, if somebody asks you, what is the average velocity of the earth around the sun? A lot of people really, they will try to find the answer. 29.5 kilometers per second. Imagine a car in 1 second moving 30 kilometers. You'll say it's not possible. But you're forgetting, you, me, every living organism on the surface of the earth, every second of our life, we are moving at a speed of 30 kilometers per second. And if you take the moon, it is going around the earth at a speed of 1.022 kilometers per second. I told you that this inclination of two axes are important. I just wanted to mention that the part of our cosmic consciousness is that the presence of life, that we are alive, that we are thriving as human race or any living organism, is a matter of chance. This is one example. It is because of the tilt of this spinning axis in comparison to the rotation axis of Earth, seasons changes. Change of seasons occurs because you see, when Earth is on this left-hand side of the sun, because of the tilt, sunlight is falling directly onto the north and slantingly onto the south. It is summer in the north, winter in the south. 6 months later, when Earth is on the other side, because of the tilt, sunlight is now falling directly onto the south and slantingly onto the north. And it is summer in the south, winter in the north. You may again ask me, okay, I understand, because of the tilt, season changes occur, but what is the big deal about it? Do you know if there were no change of seasons, what would have happened on Earth? If there were no change of seasons, there would have been no ocean currents. If there were no ocean currents, there would have been no air currents in our atmosphere. And if there are no air currents in our atmosphere, clouds would not have born somewhere and gathered somewhere else and gave us rain and fresh water. Life would not have been possible on Earth because just after it was born, Earth would have been a barren desert. So my friends, that you and me exist is because of this accidental tilt of 23.5 degrees. Solar eclipse. You all know about it. Sun on one side, moon in the middle, Earth on the other side, sun's rays falling onto the moon, moon's shadow falling onto a small patch of space, and people staying on that patch of space at that point of time will see as if the sun has vanished. Taken from space, it's a spectacular picture. You see how the shadow of the moon has fallen on a part of the globe of the earth. And people staying on that patch at that point of time will see a total solar eclipse. And this picture is amazing. As the earth is spinning, see how the shadow of the moon crosses a part of the globe of the earth. This path is called the path of total solar eclipse, and at the maximum it can be around 900 kilometers in thickness. You are all aware of this eclipse date because just less than a month back, I think you have all witnessed a fantastic partial eclipse. For people who stayed a little northward of Delhi, for example in Dehradun or Uttarakhand area, Joshimath, they have seen the fantastic annular solar eclipse, where the moon, with respect to the earth, is at such a distance that it becomes a little smaller than the average and that cannot cover the sun. So we see an annulus or a ring of fire around the moon's shadow. Amazing picture. It was during a total solar eclipse, sun was discovered as a new avatar. They found out from the surface of the sun, milky white radiation is coming out which cannot be seen on the other times. When they asked themselves the question, what is causing this, they were amazed with the answer. They found out from the surface of the sun every second, 16 lakh tons, 1.6 million tons of charged particles are coming out. These charged particles, as they move through the magnetic field of the sun, they produce this milky white radiation. The average velocity of these charged particles are 450 kilometers per second. At that speed, they have enough momentum. If they hit any atom or molecule, it will instantaneously break apart. So basically it means if I stop my lecture and go out and stand on the sun, these charged particles coming from the surface of the sun, the moment they hit my body, instantaneously my whole body should disintegrate, vaporize, but I'm alive. How? I will come to know and tell you about that. Tides. My friend, tides play a tremendously important role in evolution of life on land. Because we have all studied that life first occurred on the oceans. How did it come onto the land? Suddenly they grew legs and climbed onto the land? No. Every high tide, multicellular organisms used to get washed ashore. Water used to go down, but they used to get stranded on the land and used to get killed. Over millions of years, they got the adaptation of staying alive on land, and from there, different animals, different organisms happened, monkeys happened, and from the monkeys, we have arrived. So that we are here is because tides are there. If I ask you the question, why does tide occur, I think everybody knows the answer, probably. They will say it is the moon's gravitational attraction on the water body on the earth which causes the tide. But my friend, those of you at least in class 10 or 11 knows the Newton's laws of gravity, Ga1 m2 by r square. If you do a small calculation at the back of the envelope calculation today evening, you can show yourself sun is attracting the earth 173 times more than the moon. Then why do you say it is moon which is important? Because, my friend, tide is not a force. It is rather the resultant of quite a number of force over unit distance or a force derivative. So effectively the formula is m1 m2 by r cube. That is the reason, since moon is 384,000 kilometers away and sun is 15 crore kilometers away, moon wins. But a lot of our teachers failed to tell us in our childhood, sun also attracts the water on the earth. Do you know how much? 47% than the moon does. Amazing. Now you tell me, suppose the moon is going round the earth, the earth is spinning. At one point of time, one particular geographical region faces the moon. You will expect a high tide there. After 24 hours, that particular region will again come back there, and you will again experience another high tide. But how many high tides a day? 2. Why? Because, as I told you, tide is an interplay between the gravitational force of the moon and the centrifugal force faced by the earth, balancing the centripetal force that the moon experiences as it goes round the earth. So, on the side where we are facing the moon, the two forces are such that the gravitational force is much more. As a result, water bulges towards the moon. But just in the antipodal direction, 180 degrees away, the centrifugal force becomes more and the water bulges in this direction. So that is the reason we get 2 high tides a day. Beautiful picture taken from the surface of the moon, Earth arising from the horizon. What is moon? According to the scientists, 452 crore years back, or 4.52 billion years back, a huge ball of rock came and slammed onto the earth with such a force, huge amount of surface material got gouged up and was thrown up in space. It couldn't go away forever, but going to a very vast distance for millions of years, it condensed, coagulated, coalesced, and has given birth to our moon. This theory goes by the name, the collision ejection theory. Though there are quite a number of theories, but 99% of the scientists believe in this theory because of some convincing proof about this particular hypothesis. I think it is now our time in this short journey to go out of our earthly bounds into space and time. Why I'm using the word space and time? Definitely a journey is change in space, but time, yes. Because in 1905, Albert Einstein gave his special theory of relativity, and out of that theory we could understand that light travels at a constant speed in a particular medium at a velocity of 3 lakh kilometers per second. The distance between sun and earth is 15 crore. 3 lakh kilometers per second is the velocity. If we do a simple division, any class 6, 7 geography textbook will tell you the distance between sun and earth is 8.3 light minutes. But what does it physically mean? Physically it means if you go out and stand on the sun and look at the sun and have to tell yourself, the sun I am seeing, no, it is the image of the sun as it was 8.3 minutes back, and I'm seeing it now. Amazing. The closest star, Proxima Centauri, 4.2 light years away. If you see it today in the evening, you tell yourself the star that you are seeing is the image of the star as it was 4.2 years back. So my friend, next time your younger brother or sister requests you or your parents to take you to the Science City and spend $50 on a time machine ride, never. In a very clear night, go out into the open, tilt your head. The deeper you are seeing your own past. We don't realize that most of the time, that when we look into the night sky, we are doing a time travel in our past. Amazing feeling. The solar system, these are the true color pictures of the main avatars. Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You all know that probably Pluto has been kicked out. Sun. What is sun? Sun is a ball of gas. My friends, if I take a football, pump in a lot of colored gas, cut open the football, will the gas remain like a ball inside? It will diffuse out. Then how come sun being a ball of gas is not diffusing out into the night sky, into the sky? The answer is, according to the scientists, 460 crore years back or 4.6 billion years back, a huge cloud of gas and dust was floating in space. This cloud was made up of 91% hydrogen, 8% helium, and 1% rest other elements. The average temperature of this gas cloud was minus 240 degrees centigrade. At minus 240 degrees centigrade, out of the four fundamental forces of nature, only one type of force comes into play, and that is the force of self-gravity. The force of self-gravity will attract the periphery of this gas cloud towards the center. As the gas goes toward the central density rises, pressure builds up, and as the pressure builds up, temperature rises. And starting from minus 240 degrees centigrade, the temperature rose to a fascinating level of 1.5 crore degrees centigrade. And at that temperature, one thing happens. Four hydrogen nuclei, four protons, they as if come together, as if fuse together and produce a helium nucleus. This thermonuclear fusion reaction produces tremendous amount of energy. And this energy, as it tries to come out from the central region, it produces a radiation pressure or a back pressure. This radiation pressure, when it exactly balances the inward force of gravity and actually cancels each other, sun being a ball of gas remains hanging there for millions of years. This condition is called the condition of hydrostatic equilibrium. How did the solar system happen? According to the scientists, this huge cloud of gas, almost spherical, with a spin. So because of the gravitational contraction, as it was becoming smaller, it never became a small sphere. Because of the spin, because of the conservation of angular momentum, it all condensed into a disk. At the central part of the disk, where the temperature rose to 1.5 crore, sun is born, and in the outer periphery, where the temperature was less, gas and dust condensed, coagulated, and gave birth to our planetary system. If I bring down the sun on the earth and cut it open like a watermelon, inside there are three regions. The very central region where the thermonuclear fusion reaction is going on is called the core. And the energy that is produced at the center, for a huge volume, it freely flows out. It's called the radiative zone. And sun, my friend, is funny looking. From the surface up to a depth of 650 to 700 kilometers, pillars of gas, columns of gas stacked one after another. Heat comes from inside, hits the bottom layer of the gas pillar. Gas, when it is heated, rises up, comes to the surface, deposits the heat as sunlight, being cold like a fountain, goes down and continuously drains the heat from inside. It is called the convective zone. Outwardly, sun is again divided into three regions. The sun that you see in the early morning or late evening, called photosphere. Over the photosphere, in a very thin layer, exquisitely pink colored gas is in a chromosphere. And over the chromosphere, for hundreds and thousands of kilometers, a milky white radiation called corona. The word corona has nothing to do with coronavirus. It is rather derived from Latin, which means crown, as if sun is wearing a crown. On the left-hand side, you can see the actual surface of the moon, of the sun. And you see those granulations? Each is a column of gas. As the heat is coming through the central region of each column, it is lighted. The moment it comes from the surface, deposits the heat as sunlight, becoming cold, going down like a fountain. It is typically dark in color, the boundary, the periphery. The average size of each of these cells is around 950 to 1,000 kilometers in diameter. The lower right picture is that of a chromosphere. During a total solar eclipse, you get to see these beautiful spikes of gas called spicules coming out from the surface of the sun. And this is one of the best picture nature can provide us. corona, solar corona. You can see during a total solar eclipse this milky white radiation coming out from the surface of the sun. Sun sometimes becomes very active. You get to see black splotches or kale dhabbas on the surface of the sun. Sometimes one, sometimes 10, 20 in a group. They are called sunspots. What are they? The surface temperature of sun is around 5,500 degrees centigrade. At 5,500 degrees centigrade, out of the four fundamental forces of nature, only one type of force comes into play. Sorry. At 5,500 degrees centigrade, gas cannot remain as gas, it becomes plasma. So wherever there is a plasma, wherever plasma has a property, wherever there is a magnetic field, plasma will try to get deflected from it. On the surface of the sun, very randomly small pockets of magnetic field occurs. And if a plasma column trying to bring the heat from inside, if it realizes that there is a magnetic field at the top of it, it will not come out straight. It will take the heat away from different directions, and there will be no heat coming from that region comparatively, and we call it a sunspot. So sunspots are basically signatures of magnetic activity on the surface of the sun. This is an amazing picture taken by Solar Dynamical Observatory around 7-8 years back. The cost of the project was $1.2 billion. Why? Because, my friend, sun is not a smooth object as you see in the early morning or late evening. Tremendous amount of explosions are happening at every second on the surface of the sun. Thousands of tons of gas are getting thrown out from the surface, reaching a height of 20 to 25,000 kilometers, making beautiful arch and loops, falling back onto the surface. Sometimes they get thrown with such a force they get detached from the surface of the sun and flow past the whole solar system like a solar wind or a sometimes solar storm. The next picture describes it amazingly. You see this? This is a true picture. You see this arch, gas coming out and falling back. Do you know what is the size of this cavity? 3 Earth will go side by side inside this region. So my friend, though we have taken sun for granted, but it is an amazing, amazing object in the sky. And I told you, this charged particle coming from the surface of the sun, if they hit anybody, anything, instantaneously it will break apart. That means instantaneously we will die. But while we are alive, again, by just a sheer chance, our Earth behaves like a bar magnet because of the rotating core, which is molten at a temperature of 3,500 degrees, and an electric current loop is formed, and as a result, the magnetic axis is just across the north and south pole, and we have a magnetic field, a shield. This charged particle coming from the surface of the sun, the slam onto the magnetic field cannot flow past the Earth, and we think we are the king and queen of ourselves. But in the northern and southern magnetic polar region, there is this open field lines. The charged particles, they come along these open field lines, interact with the air molecules before hitting the Earth, and make the air glow. And what we get to see? Auroras. Aurora borealis in the north, aurora australis in the south. This is one of the beautiful pictures I have experienced long time back, but it gives you the fantastic picture as well as the realization, the conscious thoughts that sun is interacting with Earth every second of our existence. And to know about this coronal region, you know, a couple of years back, the Parker Solar Probe was sent. It will go very close to the sun, not exactly on the sun, but close to the sun to understand the properties, the physical properties of those regions, which will ultimately help us in making our lives better. Because the solar storms, the solar wind, can create havoc with our ionosphere, with our magnetic structure, geomagnetic structure, thereby hampering our telecommunication system, thereby sometimes destroying the communication with our satellites. So it's very, very important to know about it. The solar system. I mentioned to you how did it happen. 460 crore years back, when the disk of the dust and gas, at the center sun was getting burned, in the outer periphery where the temperature was less, gas and dust condensed, coagulated, gave birth to very hot spherical objects. For millions of years, they dissipated away the heat, and at least the first four, Mercury, Venus, Earth, and Mars, became rocky, solid, terrestrial, whereas the outer planets, Jupiter, Saturn, Uranus, and Neptune, are mostly made up of gas. This is a collage of all true color pictures of the planets. I'm not going to discuss everything today because I have so many things to talk to you and not a limited time. But just to give you an idea, even the arch neighbor, Venus, you cannot see the surface of Venus, covered by thick layer of cloud. The cloud is made up of mostly concentrated sulfuric acid vapors. When it rains on Venus, it is droplets of sulfuric acid which falls from the sky. The average atmosphere is around 95-96% carbon dioxide. As a result, the greenhouse effect is so critical. It being the second planet is still the hottest planet of the solar system. We will not discuss about our mother Earth tonight, but the red planet, our next neighbor, Mars, amazing color. You know why it is red? Because it is rusting on the surface. Ferrous and ferric oxide covers most of the surface of the Mars. But this 2002 photograph taken by Hubble Space Telescope have interested the scientists because in the northern and southern polar region, they have found a white sediment. According to them, this white sediment is a mixture of water ice, dry ice, that is carbon dioxide ice, and ammonia ice. According to them, even if a part of it is water ice, maybe liquid water is to flow on the surface of Mars long years back. And if liquid water was there on Earth, even a single drop of liquid water is synonymous with life. So was there life on Mars? Is there still life on Mars? Big question. And then comes Jupiter, the biggest one, takes 11.87 years to go around the sun once, but takes only 10 hours to go around itself. Then the beauty of the solar system, Saturn, Uranus with a ring, Neptune blue in color covered by methane, and till some years back, our Nanne Munne, the smallest planet, Pluto, with few of its measured moons, Charon, Nix, and Hydra. I told you, Mars has gained the center stage of attention for the last 10-15 years. Not that it is the scientists are just spending huge amount of money and spending a nice time talking about Mars, sending missions to Mars, and telling others that we are doing a lot of research. Mars is important, even from the human civilization point of view, because there are these features that has been seen on the surface, as if liquid water has cut through the rocky region and created these sort of troughs. See for yourself, 2008, when Phoenix landed onto Mars on the 20th day of operation, as it scratched a little bit, they found this whitish sediment. Then you see this in the insect after 4 days, not to be seen. This is probably for the first time human civilization have found proof of water ice outside the boundary of Earth. And the next picture is amazing. This is a sidewall of a trough, of a crater on Mars. This is actually the summer, where you see these black fingers, and then it is winter. Scientists now know these were liquid water floating on the surface of Mars. Very salty, almost brine, but water. That had geared the scientists, energized the scientists, and as a result, in 2012, Curiosity landed onto Mars. One of the first photographs it sent is an amazing, especially in the northern India during the summer when you are passing over a riverine tract on a rail bridge, you will see totally dried up riverbeds. Rainy season it gets flooded. Totally dried up riverbeds, not on Earth, but in Mars. You see pebbles, which can only occur if stones are rolling through water, getting smashed, broken, and becoming smooth because of the rolling water. And here you see pebbles on Mars. So definitely, there was liquid water on Mars. And when the whole world in 2012 was jumping up and down what to do, what not to do, 15th of August 2012, the then Prime Minister of India declared that India is ready for Mars mission. Believe me, my friend, most of the world started laughing. India, does it have the capability to send a mission successfully to Mars? Starting from 1957 till today, around 55 missions have been sent. Out of 55, only 22 have been successful, and none in the first attempt by no other country. But I think you all have shared the history. You all know the beauty of the Indian space program. And on 6th of December 2013, sitting on a nose cone of a PSLV X-25 rocket, from the Sriharikota Satish Dhawan Space Center, our Mangalyaan was sent onto space. And almost after a period of 7.5 months, on 24th September, we got up in the morning and get to know that at 8:02 a.m., successfully, Mars Orbiter mission, or Mangalyaan, has entered the Martian orbit. Amazing success. It's an amazing story for the golden march of Indian Space Research Organization. Sometimes you get to see news items, sometimes you get to see articles in social media, newspaper, criticizing heavily the Indian space program, or the efficacy, or the technological capability. My friend, believe me, I'm not a part of this project or ISRO or any governmental effort, but I can tell you, each Indian should be tremendously proud of the achievement of the Indian scientists. And the pace is tremendous, because the future has already been laid out in front of Indian people. Indian scientists are advancing more and more. And why I am saying this? Because another 10-15 years down the line, you people will be doing this. See the picture, the high resolution of the camera built by the ISRO scientists. From 2-dimensional photography, you can make a 3-dimensional topography. Saturn, the beauty of the ring system, almost 3.5 lakh kilometers wide, 1 to 100 kilometers in thickness. So physically, how does it mean? What is the size? Here you see this in the infographic. I will say, I put Earth in the actual ratio of the size, and you see what small Earth is, how small Earth is. And amazing, this ring is made out of ice crystals and pebbles. How come ice crystals and pebbles are not getting dissipated, keeping their shape and size going round Saturn, is an amazing story. And you all have read about the famous video on the utterings of Carl Sagan, the pale blue dawn. Imagine, if you are near the ring system of Saturn and you meet an alien, I don't know what is an alien, suppose you meet an alien and it asks you, who are you? What answer you have to give? You have to only say, you see those dots in the sky, that white dot? 780 crore of us, billions of other forms of life, all rivers, mountains, everything is actually concentrated into this point. Astronomy does fantastic things about its ego. We realize only when going out into the space and looking onto the Earth that how small, how insignificant we are compared to the whole grand design of the cosmos. 1801, Italian astronomer Giuseppe Piazza discovered a piece of rock, typically 900 kilometers in diameter between the orbit of Mars and Jupiter, named it Ceres. People thought a new planet has been discovered, but within a couple of years, 3 more, Pallas, Vesta, and Juno, each around 500 kilometers in diameter, were discovered in the same region. People realized a new class of object is getting discovered. And starting from 1801 till today, thousands and thousands and thousands pieces of rock, 10, 20, 30, 40, 100 kilometers have been discovered, going round the sun between the orbit of Mars and Jupiter. They are called asteroids. The next picture is mind-boggling. It's a true representation of NASA. Here each green dot is a discovered asteroid. Believe me, they are all going around the sun. And these red dots, they are called Apollo asteroids. The speciality, their orbit intersects the orbit of Earth. That means Earth is going around the sun on its own. They can come and hit the Earth at any point of time. And recently, in the recent times, we are facing this. Some of them fake news, obviously, but sometimes, because in 24th of July, this coming 24th of July, around 110 meters size rock is going to pass by the Earth. It is never going to hit the Earth because the distance at that time will be more than 5 lakh kilometers. So it's quite a far away. How many of you know that June 7th, scientists realized a 100-meter rock has passed by the Earth on 7th of June and 5th of June. Amazing. Because those were not discovered. So that we are alive, we are happy, is just by sheer chance, my friend. And lot of ideas are floating around. Whether we can send an atomic bomb in a rocket and explode it near an Earth approaching asteroid, but it had its own problem. Either we can have what are known as gravity tractors, huge massive object trying to deflect the asteroids from its orbit by gravitational interaction with it, or to attach a huge solar cell whereby the charged particle coming out from the surface of the sun, as they hit this cell, they will put a pressure and slowly drive away the asteroid from its trajectory of hitting the Earth. So, but nothing has been proved yet, and no method is actually 100% foolproof. So, still, what is going on? In the meantime, scientists all over, they are interested to know more about asteroids. That is the reason Hayabusa, a Japanese spacecraft, went very close to an asteroid called Itakawa 8. And they found, amazingly, it's not a solid rock. It is loose gravels and pebbles, all bound together by gravity. And not only that, they have found interesting things. Because only in the last year, Hayabusa 2 landed onto an asteroid called Ryugu. And the picture that you are seeing on the down is the actual picture for the first time from the surface of an asteroid, the close-up picture. And they have found huge amount of mineral deposits which could be used for the betterment of the human society and human civilization. That is the reason the word asteroid mining is becoming more and more important and prevalent. Yes, I think you are all energized by this comet Neowise, right? Just after the evening, another 1.5 hours later, you'll probably see in the northwestern horizon the beauty of a comet. What is a comet? According to the scientists, 460 crore years back, when Sun and the other planets were getting born from the disk of gas and dust in the outer periphery, beyond Uranus, beyond Neptune, beyond Pluto, where the average temperature was minus 150 to minus 20 degrees centigrade, big chunks of ice, water ice, ammonia ice, dry ice were floating around. These chunks of ice, through soft collision, collided with each other, became bigger and bigger. The moment they became the size of around 15 to 20 kilometers, sometimes 10 to 12 kilometers, they started going around the sun in extremely elliptic orbit. In the elliptic orbit, as they came close to the sun, by the sun's heat, the ice melted and created a 1,000,000 kilometers long tail. What is at present happening with Neowise, which was discovered only in 27th of March this year, right? So comets are basically, they originate from the far-flung region of the solar system, but they come in a very elliptic orbit around the sun and gives this fantastic show whenever they're in the neighborhood of the sun. Are there 9 planets in the solar system? The question getting started asked from 2003, when the scientists discovered a new object in the far-flung outer region of the solar system, around 1,600 crore kilometers away from sun, by an object which was initially named as 2003 UB313. Now the official name given is Eris, E-R-I-S. It takes 557 years to go around the sun once, and it is larger than Pluto. So what will you call it? If you call Pluto a planet, this should also be a planet. Tremendous debate, and ultimately the scientists decided that Pluto was never seriously considered as a planet because of 3 things. Because its orbit around the sun is extremely eccentric, unlike the other planets. Because most of the planets are going around the sun on a plane. Pluto makes an angle of 17 degrees with the plane and goes around the sun. And third, Pluto's orbit takes it through a region which goes by the name the Kuiper belt, where from the cometary head, short period cometary heads arise. So Pluto was never considered a planet. And after the discovery of Eris, scientists decided in 2006 to define the solar system in a new way. They said from then on, there will be 2 classes of objects in the solar system. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. These will be called classical planets. And a new class of objects were nomenclatured, they were called dwarf planets. Who became the dwarf planet? Initially Eris, the largest, the one that was discovered, Ceres, the largest asteroid, and Pluto. But in 2015, 2 more has been incorporated into the list of the dwarf planet, called Haumea and Makemake. 2006 slogan from NASA, follow the water, try to find liquid water in our solar system. Each drop of water means life. Mars probably. Anywhere else? Yes. Europa, one of the moons of Jupiter, when they see the scratch marks, the scientists theoretically said the surface of Jupiter is 10 to 12 kilometer thick of water ice, but inside there is a huge reservoir of warm water. And this water from the inside, as it pushing outward, is creating the cracks. That this theory was correct was proved when Cassini spacecraft flew over a satellite of Saturn called Enceladus. They could see plumes of hot water geysers coming out from the surface and the fractures on the crack on the surface. So they have already tested a new instrument called Cryobot. Probably 2024 it is going to be sent on Europa and Enceladus. It will take around 5 years. When they land, it's like a drill, tremendously powerful laser at the tip of a huge bullet-like thing. The laser will be switched on through the heat of the laser. The ice will melt, it will go down, and the moment it touches the water, a small robot will come out, take photographs, and send it back to the Earth. My friend, you have to wait for another 10 years to understand. Life is not the property only of Earth. Life is an universal process. It is not particular to Earth. We haven't discovered life. That doesn't mean they are not there. Right? That's a very big understanding. It is time, my friend, in the coming 15 minutes to take you out of the solar system. I will show you two colored photographs. Amazing. The first thing you will say, where from you are getting this photograph? Because when we look into the night sky, we don't get to see all these huge colors, all these beautiful gas clouds. Where from you are getting this photograph? The answer is, the problem is with our eyes. We cannot see these colors of the stars because there is something called a perception of vision. Within 1/10 of a second, whatever will be the amount of light that enters through our pupil and falls on the retina, the optic nerve immediately takes them to the back of our head to create an image. Our eyes cannot integrate light like a CCD chip, CCD camera. If our eyes were like a CCD camera of like your mobile phone, looking at one particular direction in the sky for 10, 15, 20 hours, you could have seen almost every dot in the sky is a star. Huge gas clouds of all saturations, all color, it adorned the sky. Are all the stars like the sun? Answer yes and no. Why yes? Because most of the stars are burning hydrogen to helium at the center. Why no? Because their initial mass, their surface temperature, and their chemistry, the chemical compositions are different. In terms of mass, stars can come in the range of 0.08 to 100 times the mass of sun. The mass of sun being 2 into 10 to the power 30 kilograms. This brings me very shortly to the question of life and death of stars. Stars are born from interstellar clouds of gas and dust. What does the word mean? When you look into the sky between two stars, we see totally dark, empty. No, it is not empty. Huge gas clouds are there. We cannot see it. These are called interstellar clouds of gas and dust. In the sky, there are regions where one can see these clouds and also star formation processes. For your pleasure, my friend, true color picture of the sky. Imagine. Do you know how big is this interstellar cloud? 1,000 solar system will get born out of it. Don't mix it with the clouds that you see in your sky. It is the third planet of the solar system, the Earth, and the atmosphere you see the clouds. And 1,000 solar system will form. Can you believe the beauty? 2.5 billion pixels in this Hubble Space Telescope photograph. Each pixel will give an information. On the top region, this greenish blue is for oxygen, 5 oxygen 6. This blue is for neutral hydrogen. This yellow is for sulfur. This black is for iron. This green is either zinc or molybdenum. And this white is titanium. My friend, you have to understand, those of you who are interested in astrophysics, you have to be tremendously clever. Why? Because it is only the signal of light that comes from the stars to you. You cannot bring down a star to your lab, to your home, cut it up and put chemical, test it, smell it and say, aha, this is this. Only the signal of light you have to massage and bring out the data. So it's a tremendously back-breaking, extremely intelligent and very, very computational oriented job. See for yourself. Challenge to the human mind. Do you know what is the size of these nodules that you see over here? The nodules here, 1, 2, 3. Each nodule inside has a fully formed solar system-like system. Whole solar system within that dot. Think about the size of the whole thing. Nature is throwing a challenge to us that you say that you understand a lot of things. Now, try to understand me. I will show you a wonderful, it's a mind-boggling picture. 3 pillars of dust moving into the interstellar medium with such a speed. At the tip of them, tremendous amount of pressure is getting built up. Because of the pressure, new stars are getting born every now and then. Stellar nursing. See, my friend, we are in the neighborhood of Sun. And the closest star, 4.2 light years away. That's good. Because if nearby there are stars, the temperature would have been very high. I will not never say that there would have been no life because the temperature was such. Imagine this environment. Yes. 1 million stars in a small region called a globular cluster. If our sun was a part of this system, the average temperature on Earth at your home, at your school, would have been 300, 350 degrees centigrade. None of us would have been there. So again, it's a chance happening. How do stars die? Stars die differently in different ways, depending upon their masses. Stars with initial mass 1 to 8 times the solar mass end their life. How? Let us take the sun. Sun is burning hydrogen to helium at the center. How long? Scientists have done the calculation, have shown at the central part of the sun, enough hydrogen is there, so that it will go on burning hydrogen to helium for another roughly 500 crore years. After 500 crore years, when all the hydrogen gets converted to helium, the thermonuclear fusion reaction will stop, the radiation outside will stop, but gravity is always there, so the sun will shrink. As it shrinks, in the outer envelope region, because of this constriction, the temperature rises slowly to 1.5 crore, which is enough for hydrogen fusing to helium. So the reaction that was happening, the interaction that was happening at the core region will start happening near the surface. As a result, huge amount of energy will be produced. Gas, when heated, is expanding, so the star will become big. So after 500 crore years later, sun will become bigger and bigger and bigger. How big it will be? Ultimately, it will touch the orbit of Earth. Yes, my friend, Mercury, Venus, and Earth, much before that, will become a part of the sun. At that time, the sun will be called a red giant. Whereas at the central region, where this ball of helium, because of gravitational contraction, the temperature will rise to around 10 crore degrees centigrade. At that temperature, 3 helium nuclei will fuse together one after another and give rise to 12 carbon. But soon all helium goes on to 12 carbon. When carbon will reach, again it will become smaller, but since the initial mass was 1 to 8 times, that is not enough because at that period to produce more gravitational pressure to raise the temperature to much higher level where carbon can fuse to something else, higher and higher elements. As a result, the central object, which will be called a white dwarf, is a tremendously hot ball of carbon in the sky. You can actually sometimes see. And by that time, the outer region has become so big, it slowly starts getting detached from the central region and ultimately becomes a cloud-like region called planetary nebula. The word nebula means cloud, and in the formation stage of a planetary system, it is from the cloud that it was formed. And again, when the star is dying, it produces that cloud. Don't think it's a science fiction. You want to see the real picture? Yes. These are the real pictures of planetary nebula. And it was long, long back when me and part of my group, we all sort of found out that this material is coming out in pulses, creating shock waves. And we found out the shock waves, which moves with the typical velocity of Mach 3 to Mach 8, Mach being the velocity of sound. They produce huge amount of molecules behind the shock front. The shock front being very high, hot temperature, but behind the shock front, because of adiabatic cooling, what is called, molecules can be produced. And a vibrant subject was established around that time, astrochemistry. It is a synthesis of molecules in interstellar medium. And you want to see the molecules we could find out theoretically, which was later observed. Most of them are organic molecules. And that tells you, if somebody tells you there is life on Earth and nowhere else, he is one of the biggest fools. Life is a universal process, as I just mentioned. Any star at its death produces the raw biotic material of a life to happen. When it is seeding the other places, the other interstellar clouds, other planets, other stellar systems. Amazing. Death of stars, explosive kind. Stars whose initial mass is 8 to 25 times the mass of Sun. There, in the inside core region, hydrogen to helium, helium to carbon, then it goes on because the mass is more, the gravitational pressure is more, so the temperature can reach to tremendously high level. And starting from hydrogen, helium, carbon, oxygen, neon, magnesium, silicon, ultimately it produces iron. Iron has the highest binding energy. Howsoever pressure or temperature you give, you cannot fuse iron nuclei. As a result, the core becomes an inert iron core. And there is like a peels of an onion. There are these layers of hydrogen, helium, carbon, oxygen, so on and so forth. And when the nuclear reaction, thermonuclear reaction stops, because of gravity, all these layers start towards the core. The iron core becomes incompressible. And ultimately, when they're falling, they get a recoil and the star implodes. So most of the time you'll see it explodes. The explosion being called supernova explosion. The supernova explosion is a manifestation of tremendous amount of energy. Huge amount of energy, because at the point of explosion, the temperature reaches to such a level that starting from iron 56 in the periodic table, all the naturally occurring elements get produced in a fraction of a second. Since they're produced in a fraction of a second, they cannot be found in huge quantities even on Earth, and they are called rare earth elements on Earth. So my friend, if you ask yourself the question, an atom of iron in your blood, an atom of calcium in your bones, sodium, potassium, magnesium, zinc, whatever your body is made up of, where from they have come? The amazing answer is that they have come only from stars. Yes. Through supernova explosions, through pulsation of low mass stars, these materials got synthesized, became molecules, and ultimately proparticles. And in the truest sense of the term, it's not a poetry that I'm saying. We are all star children. Our body is made up of star dust. And that is the beginning of the biggest conscious moments about the cosmos. The part of our cosmic consciousness starts with this message that we are children of stars. That we are around on Earth is by sheer chance, accidents. That our existence is so fleeting, so temporary. And these concepts will take our minds out of the everyday fear, out of things we cannot control, like this coronavirus pandemic, and will try to lift our mind to a higher plane, leaving whatever is going to happen to us to time itself, and obviously taking precautions. But our mind should be active. Our mind should be positive, because there is no way you can tell your mind to go into a depression because of the surrounding situation. And cosmos is one place where you can find an expansion of your mind, where you can find objects, issues, events, environments, knowledge, which will tell you you are a part of a much, much bigger scheme of events in the whole cosmos. So, as I was mentioning, just 2 more minutes, most of the elements in your periodic table, apart from the synthetic elements, has been produced in astrophysical situation, except hydrogen and helium, which scientists theorize were produced just after the Big Bang. So my friend, the space that we see between stars, though it looks dark, though it looks void, no nothing, there is a huge chemistry going on continuously. It is like our Indian khichdi. Continuously things are getting churned up, synthesized. The chemistry is going on. And from this, out of this, scientists slowly are realizing that if you ask the question, where from life has come on Earth? Can we produce life on Earth? The answer is life, or rather, the first prebiotic material for life, inanimate but prebiotic material for life, came onto Earth from space. When these asteroids, these meteorites, these comets, they slammed onto the Earth with much higher frequency in the past, they may have seeded the Earth with the main objects, elements, molecules of life. This theory goes by the name panspermia, and a new subject has come out of it, astrobiology. So my friend, now you tell me, one subject, astronomy, astrophysics, astrochemistry, astrobiology, astrocomputing, astrostatistics. Can any other subject boast of this? Astronomy is becoming the mother of all subjects in our understanding, in our realization, in our consciousness. So my friend, coming at the end of the seminar, I will have to say, the advent of technology has opened a new window in our minds, and through that window, the picture, the nature, the colors, the diversity, the excitement, the energy that we are seeing in the cosmos is telling us, though we boast that we know a lot, but we have only scratched the surface. There is a lot to know for us, because it is not just for the quest of knowledge, it is also for a better understanding of who we are and for a better understanding of how to make our future a little better than what we are today. So